Okay, in this video, we'll look at linear expansivity and some calculation questions. So, linear expansivity. Linear expansivity is also called the coefficient of linear expansion. That's another name for it. Linear expansivity is also called the coefficient of linear expansion. So, what is linear expansivity? Linear expansivity can be defined as the change in length per unit length per degree rise in temperature. It can be defined as the change in length per unit length per degree rise in temperature. So this is a mathematical representation of the definition of linear expansivity. Linear expansivity, which is represented by this alpha, is equal to change in length, which is it theta L, per unit length per degree rise in temperature. Per means over. Per in mathematics means over, divided. So linear expansivity again can be defined as the change in length, which is represented by this delta L per unit length over the L1 per degree rise in temperature over the change in theta. So if you're asked, linear expansivity can be defined as the change in length per degree rise in temperature. So from this formula, our alpha is the coefficient of linear expansion, or which is also known as linear expansivity. Delta L is change in length and it is equal to L2 minus L1. L2 is the new length, L1 is the initial length. Then delta theta is change in temperature and it is equal to theta 2 minus theta 1. So one thing you should take note of here is that when the temperature or length increase to, that becomes your new temperature or length. So if you see the language, the temperature increased to or the length increased to, you should know that it is your L2 or your theta 2. So when it increased to, it becomes your new length. When the temperature increased to, it becomes your new temperature, theta 2. Then when the temperature or length increased by, when it increases by, that becomes the change in temperature or change in length. So when the temperature increases by, that becomes your delta theta, which is your change in theta. And when it increases, and when the length increases by, it becomes your delta L. So let's look at this question. The question is, a metal rod of length 1.5 meters expand by 0.0012 meters when heated from 25 degrees Celsius to 75 degrees Celsius. Calculate the linear expansivity of the metal. So the first thing we want to do is to fish out our parameters. So I read again, a metal rod of length 1.5 meters. So that means our L1 is equal to 1.5 meters. That is our initial length. Expands by. So like I said before, when something expands by, that becomes your change in length. If temperature increases by or expands by, that becomes a change in temperature. So here the length expands by. This by is what is making it change in length. So my delta L, my change in length is equal to 0.0012 meters. When heated from 25 degrees Celsius to 75 degrees Celsius. So my theta 1 in this question is equal to 25 degrees Celsius and it is heated to 2 means theta 2. So my theta 2 is equal to 75 degrees Celsius. Calculate the linear expansivity of the metal. So what we are asked to calculate is the linear expansivity alpha. So from formula, linear expansivity is equal to change in length per unit length per degree rise in temperature. So my linear expansivity will be equal to my delta L is what? Change in length is 0.0012. 0.0012 over my L1 is 1.5 times my change in theta, theta is what? So my theta 2 is 75 degrees Celsius, my theta 1 is 25 degrees Celsius. So my change in theta, theta is equal to theta 2 minus theta 1. So theta 2 is 75 and theta 1 is 25. So 75 minus 25 will be equal to 50. So my delta theta, which is change in theta, is equal to 50. So that will be times 50. So having done this, my alpha will now be equal to 0.0012 divided by 1.5 times 50 is what? So let me bring out my calculator. 1.5 times 50, that is equal to 75. So this will be 0.0012 over 75. So 0.0012 divided by 75 is what? 0.0012 divided by 75. That will be equal to, so this gave me a fraction. I will have to press this button to convert it to decimal or to the index number. So this will be 1.6 times 10 raised to the power of minus 5. So that will be equal to, my alpha will be equal to 1.6 times 10 raised to the power of minus 5 per Kelvin. This is my linear expansivity. Let's look at the next question. A copper wire of length 2 meters has a linear expansivity of 1.7 times 10 raised to the power of minus 5 per degree Celsius. If it is heated from 30 degrees Celsius to 100 degrees Celsius, find its length. So let's first of all fish out the parameters. I read again. A copper wire of length 2 meters. A copper wire of length 2 meters. So the copper wire of length 2 meters, that's our L1. L1 is equal to 2 meters, 2.0 meters. Has a linear expansivity of 1.7 times 10 raised to the power minus 5. So my linear expansivity for this copper wire is equal to 1.7 times 10 raised to the power minus 5. If it is heated from 30 degrees Celsius to 100 degrees Celsius, so if it is heated from 30 degrees Celsius to 100 degrees Celsius, my theta 1 in this question will be equal to 30, then my theta 2 will be equal to 100 degrees Celsius. Find its length. So we're looking for L2. We're looking for the length when it is heated from 30 degrees Celsius to 100 degrees Celsius. So having fished out the parameters, the next thing we want to do is to write out the formula for linear expansivity. Linear expansivity alpha is equal to change in length per unit length per degree rise in temperature. So linear expansivity has been given to us, which is 1.7 times 10 raised to the power of minus 5 is equal to, my change in length, I don't know, so I'll put that as delta L. That's what I'm looking for. Over my L1 is 2. Then my change in theta, delta theta, change in theta is equal to theta 2 minus theta 1. My theta 2 is 100 and my theta 1 is 30 degrees Celsius. So if I subtract this, it will be 100 minus 30 and that will give me 70 degrees Celsius. So my change in theta in this question is 70 degrees. So this will be 2 times 70. So having done this, the next thing that you want to do is to cross multiply. This is like 1.7 times 10 raised to the power of minus 5 over 1. So the next thing you want to do is to cross multiply. So my change in length, delta L, will be equal to 1.7 times 10 raised to the power of minus 5 times 2 times 70 is 140. So my change in length will be equal to 1.7 times 10 raised to the power of minus 5 times 140. So I'll bring out my calculator and punch that 1.7 times 10 raised to the power of minus 5 times 140. That will be equal to, I'll press this to change it to decimal. So that will be equal to 2.38 times 10 raised to the power of minus 3. 2.38 times 10 raised to the power of minus 3. And this is the same thing as 0.00123, representing this power of minus 3, 238 meters. So this is my change in length. So if this is my change in length, what we are asked to look for is to find its length, the new length, L2. So you should know that your delta L is equal to, your change in length is equal to L2 minus L1. So I've gotten my delta L, change in length to be 0.00238. So 0.00238 will be equal to, my L2 is what I'm looking for, L2 minus my L1 is 2 meters, 2. So if I take this 2 to the other side of the equation, this minus 2 to the other side of the equation, it will become plus 2. So that would be 0.00238 plus 2 is equal to L2. So 0.00238 will be 2.00238 is equal to L2. So my L2 therefore is equal to 2.00238 meters. This is the answer to this question. So this is actually very simple. The first thing you want to do is to first of all fish out your parameters. And you can fish out the parameters correctly when you read the question carefully. And then after that, bring out your formula for linear expansivity. And it is equal to change in length per unit length per degree rise in temperature. So all you just need to do is to impute your values, and then you arrive at your answer.